Hello everyone, we are Virtual Engineer and this is the three-phase circuits laboratory of Electroverse. And in this video we're going to connect a balanced three-phase resistor to show you how it works, how the currents behave in the circuit. Our circuit will look like this. So here we have the first phase here, then another phase, and right here is yet another phase. I can label these as A, B, and C. And moving on from here, guys, I have a resistor, followed by another resistor, and one more resistor. How are we going to connect this? We connect them here, then over here, and finally like this. Next, we will also connect several ammeters in series to clearly demonstrate these perfectly balanced currents. Alright, so we will have these specific ammeters placed in series within the circuit, guys. Now, how exactly could I go about connecting this entire circuit together? Another way to show it is like this. Source. This is a very strong connection. And here it is even more firmly grounded than before, providing a solid foundation. And right over here, we have a resistor, another resistor, and one more resistor connected right here. This represents an alternative method for establishing the connection, and the electrical current flowing through the circuit will remain exactly the same throughout. We can observe the relationship where the voltage V is defined over the current I and then distributed over the first impedance Z as well as the second impedance Z. All right, so let's go. We'll calculate this here later. When everything is set up, we'll put the resistance of the circuit. I'm going to take these two ammeters to the table. This one I will a little more this way. Let's also connect this voltmeter so we can see the voltages. Phase. I'm going to log the equipment here. All right then, let's go ahead and begin making the necessary connections for phase A right now. I'm going to use a blue cable. I'll get 25 here. Now for phase B, I'm going to use a white cable for this part. And phase C, I'm specifically going to use a bright red cable for this, right now. Guys, so I've made these first connections here, which are the outer ones. Now I need to do the closing, which is this part here. Closing. I'm going to use a small black cable. I'm here making the closing of my load. It's a purely resistive load. which essentially means that I will have both the electrical current and the voltage perfectly in phase. And finally, I am going to set up and connect the digital voltmeter. For this task, I'll use the yellow one. Alright guys, everything is connected, everything is hooked up, let's power it on. Here, let's set a resistance close to 127 ohms. Let's see if that's possible. There we go guys, it's pretty close, 129, 132, it's very close, so we're going to have to apply 127 volts. And we have a resistance of about 132 ohms, so our current will be measured at approximately 0.9, 0.92 amperes, which is exactly what we expected to see here. So let's go. I'm going to turn it on. I'm going to apply 127 here. Balance the phases. There we go guys. What am I seeing here? Currents are practically balanced at 0.96 with 0.96 with 0.97 because the resistance is a little lower here on phase A, so I have a slightly higher current. And the voltage phase to phase, I have a voltage phase to phase of 220. So my line current, which is equal to the phase current, 0.96, my phase voltage, 126.58. My line voltage, or phase to phase, is 219.5, 220 volts. Right, guys? Fossorially, balanced circuits, voltage 0, minus 120, 120, practically balanced fossorially. And here at the source, it's the same thing. The source then is applying these voltages here. Balanced system. Well, folks, that's it for today's video. That's what I wanted to show you. Take care and see you next time.